Have any of you ever been to Small Cakes? It's really good, isn't it? So you should go. It's really delicious. They have different cupcakes every day, and they're really, really good. So we're just going to talk about first, not even the probability of something happening, but today we're just going to talk about how many choices do we have. Like in those baseball games where the guy kept hitting the ball to the exact same area, or when they hit both home runs to literally the same guy in that red shirt, how many options did they even have? Like, to even find out the probability, you have to know how many options there are. So today we're just going to talk about options. So if you walk into Small Cakes and you wanted to design your own cupcake, how many options, how many combinations could you come up with? Well, okay. So there's 3 different cake choices. We've got chocolate, vanilla, and red velvet. For icing, we've got buttercream, chocolate, caramel, fudge, and cream cheese. And the toppings are sprinkles, pretzels, Oreos, caramel, and nuts. So how could we go about finding how many different possible combinations there are of cupcakes? What do you think, Nasia?
Well, the long way would be to put the first choice with the first choice and
so like this.
First choice on the last one. Yeah.
Right.
Like that.
Is it 4 times 6 times 6? No.
Well, keep going, Nasia, and then we'll go to Ashley's idea.
I mean, the number of combinations would be like 75 in the end.
It'd be 75? Okay. And Ashley, what are you suggesting?
3 times 6 times.
3 times, how many are there?
5.
5 times 5. Try that in your calculator. 3 times 5 times 5. They were both right. Look at that. So how many different combinations of cupcakes could you come up with? 75 different combinations. So that's the first thing on your notes page. It is called the fundamental counting principle. And Nasia and Ashley got it down packed. The fundamental counting principle. Write it down in that first blank. Fundamental, other side. Okay. No, you're on the right side. Fundamental counting principle. If there are, I'm sorry, Dimitri. If there are N items and M ways to choose a first item, then to choose the next one, you keep going until you're out of options. That kind of looks like, what does that kind of look like? Maybe something we were doing in the warm-up, maybe? We'll get to it. Looks like what? Text message. All right, so you try this one on your own. You know how to do it now. You're going to make a yogurt parfait. You choose 1 flavor of yogurt, 1 fruit topping, and 1 nut topping. How many choices are there? So you find it out yourself. Don't yell it out loud. You should be typing numbers into your calculator. How many choices, how many different parfaits could you make? Catherine, how do we do this one? What do we put in our calculator? How many flavors are there? 2. How many fruits are there? 5. And how many different nuts are there? Okay. Paige, what'd you get? 30 different choices. 30 choices of parfaits. Y'all totally understand that, so we're going to move on.
It's not hard.
I mean, we're going to get into something different in a minute. All right, you're going to make a password for a website. It's going to have 5 letters followed by 1 number. How many possibilities are there?
Wow.
Well, we're about to find out. Oh, do you want to see what this says? I know it's old. Worst passwords of 2012. But anyways, what's the number 1 worst password? Password. And then 1, 2, 3, 4, 5, 6. And then ABC 1, 2, 3. I don't know what that one is. QWERTY? I don't know. Monkey.
I got the top key. Like the first
Oh, gotcha. Good job. Monkey, let me in. Dragon, 11111. Baseball. Anyways, those are apparently the worst passwords.
My password.
All right, so how many digits is this password going to have? Not digits, but how many different parts? 6. 5 letters followed by 1 number. So 1, 2, 3, 4, 5, 6. How many possibilities are there for slot number 1?
9.
How many letters are in the alphabet? You could put 26 different letters there. In a password, are you allowed to repeat letters? Sure you are. There's no rule saying you can't repeat what letter. So how many choices are there for slot number 2? 26. 26. They're not all 26.
Oh.
Followed by one number. How many choices are there? How many numbers are there?
It's like infinite.
No. It's just one blank.
Yeah.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. 10 choices, 0 through 9. Count the numbers 0 through 9. There's 10 numbers there. So there's 10 choices there. This will be a huge number.
11 million.
Let me give you a hint. When you put this in your calculator, you can do 26 to the 5th and then times 10. You can raise 26 to the 5th power. So,
Holy crap.
yeah, it's a large number. A lot of different
Yeah, very.
118.
to the 5th times 10. Oh, I did not mean to do that. I don't like how these calculators do that. You have to get out of the exponent. There we go. That's better.
Yeah.
All right, what number is that? Do we even know?
118,813,076.
Yeah, Nasia, you are on top of it today. Very nice. All right. Now, sometimes when we are counting things, sometimes order matters and sometimes order does not matter. So we're going to learn 2 new words today. The words are permutation. You're on the wrong side. Permutation and combination. Okay? Now, combinations. That's when order does not matter. So if I'm choosing marbles from a bag and I say, okay, what's the probability of choosing a green and red marble? It doesn't matter if I choose the green first and then the red, or if I choose the red first and then the green. But a permutation, the order does matter. When you're coming up with a password, does the order matter?
No. Yeah, because if you wrote monkey and then try to mix up the words.
Is that the same password as... Are those the same password? I used all the same letters and numbers though. Order matters. In a password, the order matters. When you're grabbing M&Ms from a bag, the order does not matter. When you have a license plate, if that's someone's license plate, but then someone else's license plate is that, it's the same exact thing except I just switched the order. Is that the same license plate? No. So sometimes order matters and sometimes order does not matter. When it matters, it's called a permutation. Say it out loud. Permutation. And when it doesn't matter, it's called a combination. Say it out loud. Combination. Okay. So those are the 2 types. A permutation, this should be on your notes. Are we on your notes? A blank is a selection. There we go. A blank. Write the word permutation. Selection of a group of objects in which order is important. So underline that right there. Order is important.
It's already.
It's already underlined? Cool. All right. And I don't really, well, we can talk about it real quick.
Well, let's not.
Well, don't read all those words. Just look at the tree. So, if order matters, then how many ways can you arrange 3 letters? Well, actually, let's get 3 students up here. Get 3 students up here, because that's more fun than letters. I need first 3 students who would like to come up here.
Yeah.
Okay, 1, 2,
I just got the 2.
come on. Kendall or Alea, y'all are closest. Come on up. Torin, stand up.
No.
Thank you, Kendall. How many different ways could we arrange Megan, Torin, and Kendall? So here's one way. Torin, Megan, Kendall. Now move around. We've got one way. Wait. Torin. I'm glad you all have different first names, letters. Okay, now what do we have? Megan, Torin, Kendall. Move around. Megan, Kendall, Torin, move around. Kendall, Megan, Torin, are we out yet?
No.
Move around. Tell them what to do.
You have to switch.
Kendall, Torin, Megan. Last time.
Yeah. Oh, hey.
Torin, Kendall, Megan. Yay! Give me a round of applause. Thank you for coming up here. How many choices were there? 6 choices. What if order doesn't matter? What if I just said I'm just going to pick 3 students from this room. If I picked Torin, Kendall, Megan, that's the same as me picking Kendall, Torin, Megan. So if order matters, there's 6 ways. If order doesn't matter, there's just 1 way. Okay. So that's what all those words were about. Okay. You want to select and order 3 people out of a group of 7. How many permutations are there? Is this one on there? Factorial equation. No. Okay. We're going to get to this one when it says how many ways. We'll do the government one. We'll come back to that one because it's not on your notes, and I know you don't like to do ones not on your notes. Okay, factorial. Now we're getting into what was on the warm-up. Factorial. Factorial equation. So, I mean, technically this is the factorial equation. N times n minus 1 times n minus 2 times n minus 3. But if you just know what a factorial is, then that's fine with me. A factorial is a number times the number less than 1 times the number less than 2 times the number less than 3. So, yes, it does. So instead of writing the formula, you're welcome to just write an example where it says factorial formula. You can just write this. 5 factorial equals 5 times 4 times 3 times 2 times 1. You don't multiply it times 0 because then what would happen?
0.
It would equal 0. Very good. Okay. Got that. Okay. So, if we want to find how many ways that we can choose 3 people from a group of 7, which is what that question was, how many ways can we choose 3 people from a group of 7, you would do 7 factorial divided by the people you don't want. If there's 7 people and you're trying to choose 3 of them, how many people do you not want? 4 of them. So you want to divide by 4. Just watch, I'm just showing you. So you're really doing 7 factorial, but take away 4 factorial. So if there are 7 people for the first slot, okay, I'm choosing 3 people, okay? So for slot number 1, how many choices do I have? How many people are here today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So for this slot, I have 18 choices, right? Let's say I chose Alea. How many choices do I have for this slot? 17 choices. How many do I have for this slot? Do you get why we were talking about factorials? 15, 14, 13. That's why factorials have to do with probability. And then, like I said, you divide out the ones you don't want, and just like we did in the warm-up, you get to cancel out all the like terms, and then you're literally just left with 7 times 6 times 5. Nope, not times 4, because 4 got canceled. I'm only choosing 3 people, and so that's why it's just 7 times 6 times 5. All right, write this formula down. Permutation equation. Permutation equation. NPR equals N factorial over N minus R factorial. I know, that's a lot. The good thing is there's a button on the calculator for this. But we do need to practice a couple by hand. So what that is saying is if there's 7 people and I want to choose 3 of them, so that's like 7 choose 3, then you do 7 factorial over 7 minus 3 factorial, like the slide I just showed you. 7 factorial, take away 4 of them because I'm only choosing 3 out of the 7. So that's how that formula works. So I want you to see if you can find that button on your calculator. Hint, it might be on the same screen that we looked at earlier. I want you to tell me how many people were in here? 18. I want to choose 2 of you. How many ways can I choose 2 of you? 18, choose 2. See if you can figure that out in your calculator using the button in the probability menu. 18, permutation, 2. How many ways can I just grab 2 of you for...
306.
You figured it out? So you have to type the 18, then you have to go find the button, the NPR button, and then you have to type 2. So I will show you. First you have to type 18, Then you go to math, you go over to probability, and this is number 2. 18, and then permutation, and then I want to choose 2 of you guys. Good job. There are 306 ways that I could choose 2 of you. Choose that one and that one. I could choose that one and that one. I could choose that one and that one. I could sit here and talk about it 306 times, which we obviously will not do. Okay? So that's the good news, is that there is a calculator button. If we had to do this by hand, what would it look like? 18 factorial over 18 minus 2 over 16 factorial. What would cancel? Everything from 16 to 1. So what would literally be left? 18 times 17. Those are the only 2 that wouldn't cancel. And that's like I was telling you. If I'm picking 2 students for slot number 1, how many choices do I have? 18. And then for slot number 2, how many choices do I have? 17. And then it's over because I've picked my 2 students. What's 18 times 17? Go to your calculator. What's 18 times 17? It should be 306 because that's how we do it by hand. But you will always get a calculator because there's never a time that you don't get a calculator. Okay, example number 3. We're now to the second column of your notes. I think we are. How many ways can a student council select a president, vice president, secretary, and treasurer from a group of 6 people? Does order matter?
No.
So me picking Ashley as president is the same as me picking Brett as president.
Okay.
Order matters because you're giving them a title. It's not like, oh, I'm just grabbing M&Ms from a bag and I'm going to eat them. No. Ashley being president and Brett being president are 2 different things. I could have Ashley as president and Brett as vice, or I could have Brett as president and Ashley as vice president. Those would be different councils, right? It'd be different. So order does matter. So we're going to do a permutation. So when you do a permutation, first you put how many people you get to choose from. How many people are there on the council? 6 people. 6 choose. How many positions are there, Megan? 4 positions, I think. 1, 2, 3, 4. 6 choose 4. Order matters. So figure out how many ways. Oh, the number of degrees of a circle. Look at that. So once you figure out whether it's a permutation or combination, all you have to do is press numbers in your calculator. Not too shabby. All right, now we're on to combination. This is the one when order does not matter. Combination. Order does not matter. This one's going to have its own equation. It's going to look a lot like the equation for permutation, but it's going to be a little bit different. When order doesn't matter, there's less combinations out there. So here's your formula for combination. Go ahead and write it down. In CR equals, looks the same as permutation, except it's got an extra thing in the denominator. Right. N factorial over R factorial N minus R factorial. It's okay. Yeah, that's what you have a calculator for. But you do need to see the formula and know what the calculator is actually doing when you're pressing those buttons. So if I do what we were doing earlier, we've got 18 students in the class. I want to choose 2 of them, and I don't care which order. So to me, choosing Austin Melanie is the same as choosing Melanie Austin. So if I don't care the order, I'm going to have less options. So let's see how this would work if I actually plugged it into the formula. So on top, what would I put? Yeah, what would I put? How many students are there? 18 today. In factorial. Then last time it was 18 over 16. But this one's a little bit different. What do? R factorial. What's R? How many am I choosing?
2.
So it would look like that. That's how by hand it would look. So it's exactly like last time, except I'm going to divide it by 2. Because I don't want Austin Melanie to be any different than Melanie Austin. So that's why you're dividing it by 2, if you were wondering. All right, what is 18 combination 2? Try it in your calculator. How many ways can I choose 2 people if order does not matter? Versus, what was it last time? 306?
360.
Well, 360. No, so it must have been 306 because you're just dividing it by 2. Just dividing it by 2. Yep. Okay, example number 5. The swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? Every time you need to decide if it's a permutation or combination. Because if you pick the wrong one, you will get it wrong. Which one is it? Permutation or combination? Does order matter or does order not matter? Doesn't matter. Because there are just 2 swimmers swimming in the first heat. I didn't give them names. I didn't call them president and vice president. They don't get titles. So order doesn't matter. So you can do 8. Combination, how many are we choosing? 2. 8, choose 2. 28? Okay. 8 times.
That'd be too
Okay.
bad. A little too fast.
Too fast? Okay. Any questions on this example, how this is 28, and why we chose combination? Order does not matter. Okay, let's try another one.
Look at the guy right there with the blonde hair. He's like red.
Oh, look at those kittens. I don't even like kittens, but those are pretty cute. Katie is going to adopt kittens from a litter of 11. How many ways can she choose 3 kittens to take home with her?
Okay, so it doesn't
Permutation or combination?
combination.
Does it matter in that basket which order those cute little kittens are in?
No.
Either way, they're going home with her. So it doesn't matter which one she puts in the basket first. It does not matter. So it's not a permutation, it's a combination. 11, choose 3. Dimitri, what'd you get? Oh, it's okay. Press 11, and then math. And go over, good. Yep. And we're bringing 3 kittens home. Push 3. Awesome. 165 different combinations of kittens that she could take home with her from that litter. 165 kittens. Uh-oh, Halloween party. Awards are given out at a costume party. How many ways can most creative, silliest, and best costume be awarded to 8 contestants if no one gets more than 1 award? Order matters, order doesn't matter.
Or does it does?
Does.
It does matter. And what is the difference? Why does it matter this time?
The title.
They are being given titles. They are being given titles. So Paige getting most creative and Omar getting silliest is different than Paige getting silliest and Omar getting most creative. Those are different things. So order does matter. How many contestants are there? 8. Permutation. How many awards are we giving out? 3. 8. Permutation. 3.
336.
Thank you. 336 ways to give those 8 contestants those 3 awards. Okay. Woo! We are done. Very good job. Do you like this stuff? What do you think?